All right, so with quadrilaterals, what would you say a quadrilateral is? I already said this, but what is it? What do I mean by the word quadrilateral? It's a four-side shape. Four sides, four angles. Easy peasy lemon squeezy. Now, there are special types of quadrilaterals that we deal with all the time. This is going to start feeling like elementary school a little bit because a lot of those basic quadrilaterals you've been seeing since elementary school. All right. But a lot of the features about them you didn't necessarily talk about. All right. Like, for example, rectangle. When you think rectangle, what's one of the things that comes to mind? Say it again. Okay. I mean, like if you had to describe a rectangle in a couple of words, what would you say?
Four sides.
Four sides. What else?
Two sides. Longer than the other two.
Okay. What else? What's true about the angles? They're always what? They're always 90 degrees, right? Come on, guys. I know you've been knowing rectangles since kindergarten. So 90-degree angles as the angles. They are congruent, but they're all 90 degrees. All right. And what you're going to discover is a lot of these features repeat and overlap. So let's start with one of the most basic of all special quadrilaterals, the parallelogram. All right. Now, the biggest definition of a parallelogram is that the opposite sides are parallel. It's in the name, parallelogram. All right. Now, what do I mean by an opposite side? What does that mean? Right, it's a side that's directly across from each other. In other words, they do not come together to form an angle. All right, it's almost like two lines in space, which makes sense because since they're parallel, they should never what? Cross. All right. So that's another way you can think about opposite sides. Now, if we look at our picture on the front, so the parallelogram on the front, do you see, and it's kind of light, but do you see these little arrows right here? It's faint on your paper, all right, but it is there, it's just really faint. But those are supposed to be arrows. These arrows represent that they're parallel. So I always tell my students that it's a matching game because I would put a second arrow on these two. And the reason why I did that is so we can differentiate which two sides are parallel to each other. So the ones with a singular arrow, those two sides are parallel. The ones with the double, those two sides are parallel to each other. So if you kind of see those little arrows, those mean parallel, not congruent. Congruent is just a straight line, like a little tick. All right. Now, what else is always true about a parallelogram? So any parallelogram we come across, the opposite sides will be congruent. The opposite angles will be congruent. Now, how do you know if it's an opposite angle? How do you know if two angles are opposite each other? What do you think? Just shot in the dark. How do you think you would recognize if an angle is opposite from each other? So if I go back to my parallelogram, all right, I have 4 different angles. Which two are opposite each other? It's like the 1 ticks, the 2 ticks, or one of each. What do you think? So like pairwise, would they go with the same ticks? Or right. So opposite angles. Now look at those same ticks. What's true about these angles? They're what to each other? They're diagonal from each other, or they're across from each other, guys. So in other words, they don't share a side. All right. Do you see how neither one of these two angles are formed by the same sides? That's how you know they're opposite angles. They do not share a side. All right. Same thing with these two. So those opposite angles are congruent. So those little ticks I just made, that's why I did 2 here and 1 here to identify that those angles are congruent. I'm also going to go ahead and mark the sides with the tick marks. So these are just little lines. And remember, these lines mean congruent. They're the same length. So arrows mean parallel, lines mean congruent. You need to be familiar with this notation. The last things that they mention is the consecutive angles are supplementary. What does consecutive angle mean? How do I know that two angles are consecutive? Yeah, they're back to back. They're right next to each other. They're adjacent. An easy way to remember it is they share a side. So, for example, right here, this 120 and this 35 and X right here, these are the consecutive angles because they share this one side right here. So this side right here, that's the side that they share. So those two angles will add up to 180, or they're supplementary. And then the last thing is that diagonals bisect each other. So a diagonal is literally a diagonal line that goes from, that connects the two opposite angles. So right here, this would be a diagonal, and this would be a diagonal. So it's just a line connecting the two opposite angles together. Now, they intersect at this point right here. So this point right here, because it says that the diagonals bisect each other, that point of intersection will technically be a midpoint. Now, what does it mean by a midpoint? So you learned this back in Math 1. All right, if you had a segment and there was a point on that segment and someone said it was the midpoint, what does that mean? It's exactly halfway down the segment. All right, so in other words, what's true about both sides of the segment? They're equal to each other. So that's what bisect means. So the two segments bisect each other, they create congruent baby segments. So those two little segments on opposite sides of the midpoint are congruent, and these two segments are congruent. And actually, I'm going to do 4 ticks and 3 ticks. All right. Now, the diagonals themselves, so the full line, those two full lines are not congruent in a generic parallelogram. All right. They just create congruent segments because they bisect each other. But the full segment itself are not congruent. So the diagonals are not congruent, but the diagonals do bisect each other. Does everyone understand that? All right. So, Dylan, can you shut that door for me, please? So, let's do some examples here. Now, just so you're aware, these are two completely different problems. Even though they look like they're the same, they're not. So, if we look at number 1, all right, we're just finding the angle measures for X, Y, and Z. Which angle do you guys think would be the easiest to find? Just right off the bat, we already know what that angle measure is. Z. Why? It's opposite 120, so it would be what? 120. Good. Now, take a guess. Which angle do you think will be fairly easy to find next? So, how many of you say X? How many of you say why? How many of you had no clue? Be honest. Come on. All right. I would say the next easiest one to find would be why. And here's why. All right. What's true about the opposite sides of a parallelogram besides that they're congruent? Well, they're congruent. That's the definition of congruent. But what else? They're what to each other? I heard you say it. Opposite interior angles, which so in other words, look at this, guys. So do you remember how yesterday I made you guys do those parallel line theorem stuff to find the angles with in parallel lines in a transversal? Well, is it not true? Is it not true that these two lines are parallel that I just drew? So those red lines, are they not parallel? Yes or no? They're parallel because the opposite sides of a parallelogram are parallel. Well, guess what? This diagonal is almost like a transversal or a line that cuts through the parallelogram. So if we have two lines, so two parallel lines cut by a transversal, that means we can use all of those theorems. So alternate interior, alternate exterior, same side interior, same side exterior, corresponding. All right. This is why I made you guys do this stuff yesterday. All right. So what do you think the measure of angle Y is? 35. Why? What's the relationship between these two angles here? They're alternate what? Interior. All right, they're on different sides of the transversal and they're inside the parallel lines, which means alternate interior angles are congruent. So Y would be 35 degrees. Now, I can tell you right now, angle X, we would not be using same side interior, mainly because this would come out to be 145, which would not make sense because if that would add to 180, which is not true because it's not on the straight line. All right. Since these angles right here, if you look at this angle, so see that angle right there that I just drew in purple? All right. Some people would think that X and Y would relate because they are same side interior, but technically they're not because X is technically part of this big angle right here. All right. And this angle is clearly not 180 degrees because it's not a straight line. So, what would be a strategy to find angle X then? Does anyone see a different type of shape in there? A triangle. So, do you guys see right here? What's true about a triangle, guys?
Three sides.
Three sides. But what about the angles? The angles add up to 180 degrees. Well, do we not have two of those angles already? Yes. So couldn't we just subtract 120 and 35 from 180 to get X? It'd be 25 degrees. So guys, with these problems, you have to do a lot of, you really have to finagle them to get what you want. Now, for those of you who've never heard the word finagle before, it is a keyword, and all it means is it's a fancy way of saying manipulating. For some reason, people like it when I say finagle. I don't know why. But why did you start laughing at this one? So it's almost like you kind of have to look at it like a big old puzzle. Okay, there's not always going to be a direct answer to this. Sometimes you got to kind of think outside the box a little bit. No pun intended. All right. All All right. So how many of you would have thought to think of a triangle if I didn't show it to you?
Wait, what?
How many of you would have thought to think of a triangle if I didn't show it to you?
Eventually, yeah.
Eventually, yeah. So, in other words, guys, things that you already know about certain shapes still apply here. All right. If something forms a triangle, well, the rules of a triangle apply. All right. All right. Let's do another one. So, guys, if there's ever not a picture, you need to draw a picture. All right. I can't even visualize what that would look like if I don't draw a picture. So I want to draw a parallelogram. It ain't gonna be pretty. All right. But parallelogram ABCD is a parallelogram. So measure of angle A is x, measure of angle D is 2x minus 3, and they want us to find the value of x. Now, when you label a parallelogram, you pick one angle, it doesn't matter which one, and that's your first letter. Then you pick a direction, so either clockwise or counterclockwise, and you go around it in a circle. All right. So don't write this down, but you would not label it like this. All right. That's incorrect. You would, however, label it like this: A, B, C, D. So it has to go around in a circle when you label it. All right. So you could have gone the other way and it still would have given you the correct setup. All right. Now, I'm then going to label, guys, please stop talking. So I'm now going to label the different pieces that I was given. So angle A is x, angle D is 2x minus 3. Now, let's think about the properties of parallelograms. What's true about angle A and angle D? They're not the same. They're not opposite angles. A and D. That's what I meant. If it was B and D, you'd be right. Yeah.
Yeah, that's why I was confused. I was wrong.
I meant A and D. My bad. So what's true about A and D? What are they to each other? What's the magic words that describes them? They're not opposite. They're not congruent because they're not opposite.
Same side.
They're supplementary, but why are they supplementary? They're on the same side, or what's the other word that I use? Starts with a C. Consecutive. Good. So they're consecutive. They share this side right here. So they add up to 180. So how do you think I would set up this equation? Good. You just add them together, set equal to 180.
Sorry to interrupt. Can I use the restroom? I have to go to the back.
Yeah, make sure you sign out, take the pass. So I would combine like terms. I would get 3x minus 3 is equal to 180. Add 3 to both sides. That goes away. 3x is equal to 183. And then you divide both sides by 3, and x would be equal to what? Good. Now, if they asked us to take this a step further and plug it back in to find the two angle measures, what would angle A equal? 61. What about D? So you just plug 61 back in for x and evaluate. So you, right, 119. So 2 times 61 and then subtract 3 from it. Now, is it not true that 61 plus 119 equals 180? It is true. So that's also a good way to check yourself if they just ask you to solve for x. If you know that those two angles got to equal 180, your answer, if you plug it back in for x, those two angle measures should then add up to equal 180. All right. If they don't, you probably did something wrong. All right. Any questions on parallelograms? All right. Now let's talk about a child of the parallelogram, which is the rhombus. Oh yeah, it's a child of a parallelogram. Very similar. So think about this way. I just said that a rhombus is a child of a parallelogram. Now think about the parent-child relationship. Not necessarily, but think about like you versus your parent. All right, are you an exact clone of your parent? Like DNA, everything. No, you're not exactly the same. You're similar, like you share a lot of traits, but there are still some things that make you unique. The same thing is true about a rhombus. It's very, very similar to a parallelogram. In fact, it is technically considered a parallelogram, but it has a couple more defining features. So, biggest thing about a rhombus is all four sides are congruent. It's basically a version of a square that doesn't have 90-degree angles. Now, property-wise, the properties are the exact same as a parallelogram. So all the properties that a parallelogram has, a rhombus has it too. So the opposite sides are congruent, the opposite sides are parallel, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. All of those properties, bathroom, sign out, take the pass. All of those properties show up in a rhombus, but we add a couple more. So on top of that, a rhombus also has four congruent sides. The diagonals are also perpendicular, so where they bisect at a right angle. And the diagonals bisect opposite angles, meaning they cut that angle in half. So let's go to our picture. So if I go to my picture of a rhombus, they already labeled the ticks. So all of these have one tick each, so that means all four of those sides are congruent to each other. Now, I'm not going to label all the stuff that it has in common with a parallelogram because that'll just start getting really overwhelming. I'm just going to label the stuff that makes it different from a parallelogram. So the first thing, all four sides are congruent. The second, diagonals. All right. The diagonals intersect at a right angle. They're perpendicular to each other. So that means that all of these angles right here are right angles. Those two lines are perpendicular. They still bisect each other. So that means they cut each other in half. Still not necessarily the exact same length. And then the last thing is that they bisect their angles. So the diagonals, what it does is that it takes this vertice angle right here and cuts it in half. So two equal baby angles. So these two baby angles are the same. These two baby angles are the same. The same thing here. Now, I marked these two with 1 ticks and these two with 2 ticks because remember, just like in parallelograms, those consecutive angles, not consecutive, those opposite angles are still congruent to each other. So the big angles are still congruent to each other, but the little baby angles that are formed by the diagonals are also congruent to each other. All right. So let's look at some problems and then we'll take a little break. All right. So it's asking us to find the measure of SVT if the measure of STV is 135. So let's mark my picture first. So SVT. So I'm talking about this little angle right here. And we don't know what that is. And then it says STV is 135. So this big angle right here is 135 degrees. Now, does anyone have a strategy that you think would work? to find what that little baby angle is? Dylan.
Aren't they on the same side? So shouldn't it be 180 minus 135?
So that's part of it. So that's the kind of the first step. So these two angles are on the same side. However, doing the 180 minus the 135 wouldn't give you the baby angle. It would give you this big angle. All right. But that's part of the process. That's the first step. So your first step is to do 180 minus 135 to find the big boy angle. So the papa angle of the baby angle. All right. And what is that? 45. Now that angle doesn't look like it's 45 degrees, but it's not drawn to scale. Okay. Now, since we got the big angle, how do you think I would find the baby angle? Divide it by 2. So I'll just take the 45, divide it by 2. You should get like, what is it, 22.5? Something like that. So 22.5 degrees. Because remember, these two angles, that diagonal bisects that big blue angle. So it cuts it perfectly in half. Now, another way you could have found it, because there's more than one way to skin a cat. All right. Another way you could have found it is you could have just cut the 135 in half. So what's 135 in half? 67.5. Then, remember, this angle is a right angle. So is it not true that we kind of have a triangle right here? And we know what two of the angles are now? So we could also done 90 plus 67 and a half and then subtracted from 180. And that would give us the exact same thing. So like I say, guys, there's more than one way to skin a deer. All right. Well, same thing. Any animal, really. There's more than one way to skin any animal. All right. So, guys, essentially, whatever you think would logically make sense, as long as you can justify it, it'll probably still get you to the answer. All right. Last one before break time. So, SWT is 2x plus 8, and it says to find x. So, SWT, so this angle right here, that is 2x plus 8. What's true about that angle? So, look at its placement and think about the properties of rhombuses or rhombi. That's the plural rhombus, rhombi. All right. What's true about that angle? We technically should already know what that angle measure is. So look at the placement of that angle where the 2x plus 8 is. Technically, but that would more be if we're like finding the segment length. We're trying to find the angle. So what's true about this angle right here? Not necessarily. Look where it is. It's where the two lines, it's where the two diagonals cross, right? What's true about diagonals of a rhombus? It's on your paper. Nope. 90. Remember, the diagonals of a rhombus are perpendicular to each other, meaning they cross at a 90-degree angle, which means all 4 of those angles, all the way around right here, are 90 degrees. So how do you think I want to solve for x? Right. 2x plus 8 is equal to 90. Subtract 8 from both sides. 2x is equal to 82. Divide both sides by 2. X is equal to 41. Plug that back in. You should get 90. So, guys, this is why knowing these properties are important. You need to know how to use them to answer these questions. All right. If you knew that diagonals of a rhombus, and you know it is a rhombus, intersect at a 90-degree angle, you already got half the problem done right there. All right. So we are going to take a 3-minute break. When we come back, we're going to finish rectangle and square. We'll save kite and trapezoid for tomorrow. So I want to set the timer. Make sure you're back before then. No, I'm saying is that you're going to get all the way without paths. I can get away from having a break this one if I watch it. Yeah, but if you go on the other one, that's fine. So you want to go third? All right, guys. With that, we are back to work. So let's get back to the grind. All right, we're almost done. We're only going to do rectangle and square today, and then we'll leave trapezoid and kite for tomorrow. All right. And you can count your lucky stars because we just didn't get to it in second period, so I don't want to get ahead. All right, so now we're going to look at another child of the parallelogram, and that is the rectangle. So, another child of a parallelogram is a rectangle. Now, a rectangle is not a child of the rhombus. They're more like siblings, all right? They're similar, but they're not the same. But they both stem from the parallelogram. So what's special about a rectangle? Well, the defining feature is those 4 right angles. Still has all the same properties of the parallelogram. So opposite sides are congruent, opposite sides are parallel, consecutive angles are supplementary, opposite angles are congruent, diagonals bisect each other. All right? So it still has all those properties, just like a parallelogram. But it also includes the 4 right angles, and the diagonals themselves are congruent. Now, none of the properties of a rhombus relate to a rectangle besides what they share from a parallelogram. All right, so a rectangle's diagonals are not perpendicular. All right, they do not bisect their angles. The only thing that it does is that those diagonals are congruent. So make sure you know that distinction. So, like I said, the best way to think about it is the parallelogram is the parent, the rhombus and the rectangle are the two children and their siblings. All right. So they have all the same qualities from the parent, but they don't, but every sibling is different. So they have different aspects of themselves. So if I go to the picture, all right, they already marked the right angles. So all four of these vertices are right angles. Now, the diagonals themselves. So these diagonals as a whole are congruent. So that both diagonals are the same length. So a way you can mark it to know that is that since they bisect each other, meaning they make those two congruent baby segments, all four of these baby segments should be the same length. Because they would equal the same length if you add them together for the big segment. All right. So now that we know that about rectangles, and remember, all the features of parallelogram apply to a rectangle. I'm just not going to draw them so it doesn't get really busy on that picture. All right. So remember, if you don't have a picture, you have to do what? Draw it. So we got ourselves a rectangle here. It calls itself ABCD. So ABCD. Remember, pick an angle to start with and make sure you go around the circle in order that they label it. Now, they then say that the diagonals of that rectangle intersect at the point P. So this point right here where they intersect, we're going to call it P. Now, it then says that the length of AC, so this big one right here, is equal to 4x minus 13. So that entire diagonal is equal to 4x minus 13. And then the length of DP, so the baby segment, is x plus 7. So, and they want us to find the value of x. All right, so that's what we're doing. We're finding the value of x. Now, let's think about this logically. First off, what's true about the two diagonals, so AC and DB? So what's true about AC and DB? Those two diagonals. They're not opposite, but what's true about the diagonals of a rectangle? It's on your paper, guys. The two diagonals are what? Congruent. So that means AC is congruent to DB. Now, let's relate DP to DB because it's on the same line. So what's true? Like, let's say I was given DP and I had to find the length of DB. How would I find it? Backwards. So you could cut DB in half or you could double DP. So if I multiplied DP by 2, that would give me the length of DB. Because remember, point P bisects. Point P is a midpoint because the two diagonals bisect each other because it's still a type of parallelogram. So those two little baby segments are congruent. So that means that twice the length of DP is the same thing as the length of DB. Now, so since we know that 2 times DP is equal to DB, and that AC is congruent to DB, how could I relate DP to AC? So think about logically. AC is congruent to DB, and DB is also equal to 2 times DP. So what's true about DP and AC? Nope. What's the relationship? Couldn't I just replace the DB right here with AC because they're congruent to each other? If they're the same size, wouldn't it make sense that if I multiply 2 times DP, it would be congruent to just the length of AC? Is that true? So guys, listen to me. We know that AC is equal to DP. So this segment is equal to this segment, the same length. We know that if we multiply the length of DP by 2, it'll equal DP because it's DP. If you take half of DP, you get DP. So this little segment and this little segment are congruent. So since they're the same, I can just multiply this by 2 to get this segment. We already said, however, that this segment is congruent to this segment. So is it not true that if I multiply 2 times this segment, I would also get this segment? Yes or no? Yes. All right. That's what we call the transitive property. All right. So it's just a fancy word for saying if you already said that something's equal to something else, and then you defined it for one of them, you can define it for the other. It's the same thing. So now we got a statement of how we can relate DP to AC, even though it doesn't look like they have a straight up relationship. This is how you can figure out how to set up your equation. If you just start stating things that you know, it'll eventually be like, oh, well, I already know that AC is equal to DB. And I already know that if I multiply 2 times DP, that'll also give me DB. Well, if DP is equal to AC, that means if I multiply 2 to DP, that'll give me AC as well. All right? So how do you think I'm going to set up my equation? We pretty much already did. We just got to replace it with what we're given. So if I replace DP and AC with my expressions, what will my equation look like? What's the length of DP? What did it say it is? X plus 7. So I would write 2 times x plus 7. And it's equal to what? What's AC equal to? 4x minus 13. Good. So now we got our equation. So now I can solve for x. So I distribute. So this would be 2x plus 14 is equal to 4x minus 13. To save some time, I'm going to subtract the 2x to both sides as well as add the 13 to both sides just so I can get the variable on one side and the number on the other. You could have done it separately, but you don't have to. So this is 27 is equal to 2x. Divide both sides by 2. X is equal to 13 and a half. So that is what x is equal to. All right. Any questions on that? All right. Nope. Still got square. So if a rectangle and a rhombus are the children of a parallelogram, I would say that a square is a grandchild of a parallelogram. All right? And this is going to be a Game of Thrones situation, if you know what I mean. So I would draw this somewhere on your journal, like maybe off the side. It's not a big picture, just a little diagram. So we have a parallelogram. All right. Let's say we're making a family tree here. This is more going to look like a family bush, but that's okay. So it breaks down to its two children, which is the rhombus and the rectangle. Now, from there, let's say the rhombus and the rectangle had a Lannister-like relationship. So if you've ever seen Game of Thrones, you know what I'm talking about. Incest, you guys. Incest. Right. So, let's say they had a little thing going. All right. And from that thing came the square. All right. So, the square is almost like a grandchild of the parallelogram. It comes from both a rhombus and a rectangle, and it still has features of the parallelogram as well. All right. Oh yeah, this is an Alabama situation right here. All right. So, but hey, I guarantee y'all will never forget it. Think incest. The quadrilaterals, there's some incest going on right here. All right. Because literally, if a rhombus and a rectangle had a baby, it would make a square. Literally, in terms of its properties. Wow. Yep. So. All right, so what that means is why I'm telling you this is because literally every feature that a rhombus has, a square has. Every feature that a rectangle has, a square has. Every feature that a parallelogram has, a square has. So a square is the best of everything. It has 4 right angles and 4 congruent sides. Basically the 2 defining features of a rectangle and a rhombus. So their properties are the same as a parallelogram, the same as a rectangle, and the same as a rhombus. That's why I said it's a family bush, not a family tree, because there is some overlap. All right. So you got your 4 congruent sides. You got your 90-degree angles. Your diagonals. Guys, I can guarantee you, y'all will never forget that. So, your diagonals, they are perpendicular to each other, just like with a rhombus. They are also the same length, just like with a rectangle. And they bisect each other, just like with a parallelogram. The angles themselves, also the diagonals, also bisect the angles. All right, so if I'm talking about those little baby angles, what does each one of those little baby angles have to equal? So 90 divided by 2, guys. 45. So all those little baby angles are 45. Then it has, like I said, all of the properties of all 3 of those shapes. They come together to form the square. So, that being said, let's do some deduction here. So, the length of MH, so this side right here, is 8. It then wants us to find the length of AH. Now, this is one where you kind of have to maybe not use what you would think a quadrilateral would use. So think about it. Is there another shape within this square that I could probably figure out? A triangle. There is a triangle. So the triangle I'm thinking of in question is right here. So all 3 of those colored sides are that triangle. Well, what's true about that triangle? What type of triangle is it? Nope. It is isosceles because this side would also be 8. It's not just an isosceles triangle, though. It's also a what? It's a right triangle. It got that right angle right here. All right. So if we have 2 sides already of a right triangle, how can we find the third? Nope. Need a little help from our good friend Pythagoras. Pythagorean theorem. All right. Oh, yeah. So a squared plus b squared is equal to c squared. We got a right triangle where we know 2 of the sides. So I want to do 8 squared plus 8 squared is equal to c squared, because remember, c squared is always the hypotenuse, which is the side directly across from the right angle. So what's 8 squared, guys? 64. So 64 plus 64 is equal to c squared. 128 is equal to c squared. Take the square root of both sides. C is equal to the square root of 128, and I want to leave it there. Now, this was the test I'd probably ask you to put in your calculator and round, but we're just going to leave it like that. Just know that it's probably a number between, it'll be a number between 11 and 12. So probably like 11 point something, something, something. All right. So yeah, guys, Pythagorean theorem is going to come back and haunt you a little bit here. So let's look at the next one. Last one for today. So MS is 3. So this little piece right here is 3. AS is also 3. So this little piece right here is also 3. And they want to know what the perimeter of the square math is. So the MATH. So they want to know what the perimeter of the square is. So which side would be the most beneficial for me to find? MA. So we're going to try and find this side right here. Well, what shape did I just make there? Triangle. What type of triangle? Right triangle. Why is it a right triangle? Where's the right angle? Right here where they cross. Remember, those diagonals are perpendicular to each other, so they form that right angle. Pythagorean theorem again. So 3 squared plus 3 squared equals c squared. So that's 9 plus 9 is equal to c squared. So 18 is equal to c squared. Take the square root. Square root of 18 is equal to c. So this right here is the square root of 18. But that's not what it asked. What it asked for? The perimeter. Well, let's think about this logically. If each one of these sides is square root of 18. So we're essentially, how do you find the perimeter of anything? Add all the sides together. So we're adding the same number 4 times. That's the same thing as doing what? Multiplying by 4. So would it not be true that the perimeter would just be 4 times the square root of 18? Yes. And that's our answer. So remember, if you're adding the same side 4 times together, it's the same thing as multiplying by 4. So even though it has a square root on there, you can just multiply it by 4. All right. So we're pretty much out of time. There is a delta math that you could probably do a little bit of, but we will pick this up tomorrow with isosceles and trapezoids and a kite. All right. So again, there is a delta math that you guys can at least start. But yeah, we'll pick this up tomorrow. Yes. Didn't you already go? Go.
I can't say.